Hello and welcome to the second video on the congestion control contest. In the second video I will make a short demonstration on the contest to look a bit at the code and how you should run your experiments. So let's jump right into the code, first taking a look at the files that make part of the project. So we have a sender that is already coded, a receiver, something to create the the contest message, and the controller. So the controller.cc is the most important file because it's the one that you will have to change. Of course, you can change anything else. You can also change the receiver, you can change the sender, for example, because that you can make changes to make different types of congestion control mechanisms, so you don't have to only use the controller. But this is probably more advanced, and usually you don't need to do this. So in most cases you'll only change the controller.cc file. The only thing that you should not change anyway is the run contest and run test scripts, because these are the ones the scripts that run the contest, or at least tests, to evaluate your solution. So let's look at the code now. So this is the code for senders. This is just a simple UDP sender for the contest. So it's like basically it includes all the details to open sockets and to start sending UDP datagrams, and the same for the receiver, just receives messages and acknowledges every datagram. So very simple. You can change it if you want, but in principle there is no need for that. The main thing that you should look at is the controller.cc, which is the controller class. So this is basically the core of the system. So for example, it lets you change the window size, like the initial window size. Currently for this initial basic controller we have just a window size of 1. It will always be 1. So it's very, very simple. So it's the simplest congestion control mechanism, where you only send one packet and you only have one packet in flight. But the idea is that every time that you send a datagram, you can change this method here. And so, to decide what to do when you send the packet, when you send a datagram, and also this one on every time that you receive an ACK, what do? You may update certain variables, for example, in some way, and perform some action. So this is the core of the code that you will have to change. Okay, so let's see this running. So I will start by running a test. This is the thing that you will usually do more often, probably. So in here, what you are seeing when you run the test, so basically an emulation over a cellular network is run. So you have a real trace, real packets, but it's a single trace that you use to feed a network emulator. And then you have a sender sending packets and the receiver acknowledging or sending acknowledgements. And what we see here on the left, we have throughput. So we can see in here this line is the actual throughput of your protocol. In this case, very, very low, as you can see here, because you're only sending one packet at a time. So you only have a window size of 1. That means only one packet in flight every time. And the capacity is shown in pink, so you can see that the capacity is, you have a lot of capacity that you're really not using, so you're not making a good use of the network. With respect to delay, on your right, you can see that delay is relatively low in most cases, so in the order of tens of milliseconds, which is good. So this is what you want very low delay, but of course in this case the delay is very low because you only have one packet in flight, which means that the queues are empty, and so basically latency is always low. Okay, now this will just run until for two minutes or 2 minutes or so, and so let's just fast forward. Okay, here are the results. So the average capacity was around 5 megabits per second, but unfortunately the throughput was very low of 0.20 megabits per second. So you're only utilizing 4% of the link, so it's very, very low. But the signaling delay is very acceptable. It's very, very low because you're not really using up all network, and so the queues are empty. Okay, so now let's imagine that we make some sort of change. Let's see, okay, the window size was 1 and so throughput was low, so let's just increase the window size. Let's save this and let's run make. Okay, compile everything. And now let's assume that we want to run the contest. Okay, so the difference between run contest and run test is that in run contest, besides running the test, you will also send your results to the server, to the contest server, and the server will then display these nice plots so that you can, check your results and also compare with others, because you will see the scoreboard. Okay, for run contest you have to have an argument. I will use just PRD as argument, but you can choose whatever nickname to your group you want to use. It can be an anonymous nickname if you don't want anyone to know that it's you that's sending like the results. Okay, so let's run the contest. Okay, so roughly the same thing, but you'll see that it's now the results are start to look a bit different. Let's see if this one comes on. Well, we can start by looking at the delay. Queuing delay is very high. Okay, now it's good. So let's look at the left. Throughput. So throughput now looks good. Okay, so what we see here is that we are using the capacity well. So this means that, a window size of 100 means that you are always trying to have 100 packets flying, and so you're just using entirely the network. But the problem is that you're accumulating packets in queues, and so the delay on your right goes up. So we have delays that, sometimes 1 second and sometimes more. Better use of the network, yeah, you're using the capacity, but you're filling up buffers a lot. Okay, so this is the other extreme. High throughput, but also high delay. Okay, so the results are out. So as you can see here, now we have, roughly the same capacity as expected, 5 megabits per second, but the throughput is very close to the maximum. So we have a very high utilization, close to 99%, but the problem is that now the delay is very high, so signal delay of around 1 second. This can be considered unacceptable for an interactive application. Now what's happening is that the results are being uploaded to the server. It takes some time. As I said, sometimes I don't know if I said in this video, but if I didn't, let me say that sometimes this process fails. Usually it fails at the first time sometimes, and we have to run this again. I'm not sure why. Yeah, this is the error that we get. So we will run this again, and hopefully this will run correctly now. Okay, and now it worked. So it uploaded the data to the server, and we have the report here, which we can now check, like just copying the link, opening the browser. And let's see these results. Okay, these are the results. So in here you get the initial statistics, like 96.9% utilization, etc. And you have some nice plots showing first the capacity. As we've seen, the capacity is quite good, the use of the capacity. And then, the delay will pop up in the meanwhile. And you see here the leaderboard. So in here you can see like the throughput of these schemes, the percentile, the signal delay, which is the delay that we want, and the power score. This is what matters. So your goal is to have, as high as a score as possible in this power score here. Okay? So this takes some time still, but you can, our protocol is certainly quite low here, so we can go down, but you can see that there are many students that have already participated in this contest. I found in here even Sprout, which you see here, Sprout, that algorithm that we studied, and in here you can see the leaderboard. So the results will appear. They take some time. The server is a bit slow, I guess. But in here you get all these results, and you can check where you are. Thank you very much. I hope this video was useful to help you have a good overview on this context. Good work.